In this video, I am going to go over percent yield. So this problem tells us 8.23 grams of zinc reacts with excess silver nitrate. 26.87 grams of silver is formed. What is the percent yield? So I want to start off by writing the balanced equation. We have zinc. It's going to react with silver nitrate. Silver has a positive 1 oxidation number, and nitrate has -1, so you end up getting AgNO3. Now this ends up being a single displacement reaction. Zinc is higher than silver in the activity series, which means zinc is more reactive than silver, so it is able to come in and replace silver in that bond. But zinc has a positive 2 oxidation number, and nitrate still has a -1 oxidation number, so when we write the formula for that, we have to put nitrate in parentheses and put a 2 outside of there. Silver ends up precipitating out, so we put plus Ag. Now we have to balance this. There's 2 nitrates on the product side, so I have to put a 2 in front of silver nitrate on the reactant side. Balance the silver. Now there's 1 zinc on each side, 2 silver, and 2 nitrates, so we're good. Now it is asking us to calculate percent yield. So what we have to do is figure out how do we calculate percent yield. And what you do is you take the experimental yield and divide that by the theoretical yield. Now some other ways you might hear it or see it is instead of experimental they might use the word actual, and instead of theoretical they might use the word expected. It's really telling you all the same thing though. Now since you're not actually doing the lab, we would have to give you the experimental or actual yield, and that's what this 26.87 grams is. That's the experimental or actual. But we have to figure out the theoretical, or what you should expect to get from doing that reaction. Now it tells us that there's 8.23 grams of silver, and it says there's excess silver nitrate, so that means the zinc is the limiting reactant, and that is the one that we are going to start off the problem with. Now, since it gives me mass of silver as the experimental yield, I know I have to solve silver for mass. So this ends up being a mass-to-mass problem. So start off writing what you're given, 8.23 grams of zinc. Now, what I said in that stoichiometry overview video, remember at the heart of every stoichiometry problem is a mole-to-mole ratio. So what we have to do is figure out how to go from grams of zinc to be able to do a mole-to-mole ratio of moles of zinc to moles of silver. So that's telling me if I want to get to mole-to-mole ratio, I have to convert these grams of zinc to moles. So I end up, since I have grams of zinc on the top here, I have to put grams of zinc on the bottom, and I'm going to put 1 mole of zinc up top. This is the conversion factor. And remember, in the conversion factor, it's always 1 mole for however many grams, and you get this number from the molar mass on the periodic table, and I'm just going to round it off to 1 decimal point, so that's 65.4. So now grams of zinc will cancel out. What I have right now is moles of zinc, so this is where I can finally do that mole ratio step. So if I have moles of zinc up top, I put that on the bottom in the next step. I want to figure out silver, so I have to do moles of silver. Remember, I can't go from moles of zinc to grams of silver. There's no conversion factor that lets me do that in one step. What I have to do is this mole ratio step. And this is the part where I use the coefficients from the balanced equation. It's 1 mole of zinc for every 2 moles of silver. Now moles of zinc will cancel out. Now what I have is moles of silver, but I do not want moles of silver. I want grams of silver, so this is going to be another conversion factor. Remember, the conversion factors are converting from one unit to another, and in this case it's of silver, of the same element or compound or whatever it is you're talking about. So now conversion factors get the number 1, and I get the mass for silver from the periodic table, 107.9. So notice conversion factors going from one unit to another of the same element or compound, they always get the number 1. The mole ratio, I get these numbers from the coefficients in the balanced equations. So now moles of silver will cancel out. What I'm left with, or what I will be left with, is grams of silver, and that's what I'm looking for. So I don't have to write any more steps down. I could do the math now. You do 8.23 divided by 65.4, multiplied by 2, multiplied by 107.9, and I get an answer of 27.2 grams of silver. Now, before you even do the problem and start clicking all the buttons on the calculator, it would be good to look at this 26.87. I should expect my answer to be somewhere around there. And I got an answer of 27.2, so that makes sense. It's in that ballpark range. Now, I rounded it off to 3 significant digits because the number I was given was 3 significant digits. So this ends up being my theoretical or expected yield. That's how much you should expect to get of the silver. But in reality, we only got 26.87. So now I have to do this to figure out what the percent yield is. So I take that 26.87 grams, the experimental or actual yield, divide it by the theoretical, which you get from doing the stoichiometry problem. Now that's going to give you a decimal. What we have to do is multiply that by 100 because we want it as a percent. So you get 0.988, multiply that by 100, and it's telling you a 98.8% yield, which is a pretty good yield. Now, don't get confused if you get over 100% yield. Sometimes when you do this, you might end up getting that. And there's different reasons for why that could happen. There could be some kind of contamination. There could be leftover, like unreacted reactant still in there, adding mass to it. Whatever it is might be wet. Maybe you have to let it dry a little bit more. But it can happen. So if it is over 100%, it's not necessarily telling you that you did something wrong. But that's how you do percent yield. You get a stoichiometry problem, and then you compare the experimental value, which is usually given to you, to the theoretical value, which is the one that you have to calculate.